Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com under the topic of kinematics, and it's titled, Which One Doesn't Belong? There should have been a question mark right there. And that title shows up in several different versions, so I just wanted to identify this as the kinematics version, the one in kinematics. This particular concept builder is a culmination of a lot of different learning. So right here, I'm going to link the position time graphs video, which will help you through the apprentice level, and the other two, which will talk about how to identify a position time graph compared to the words that describe it. Here, I'm going to link the dots and graphs video, which talks about how to identify a position time graph and velocity time graph from dot diagrams. The velocity time won't come up until the master level, I believe. Here's the velocity time graphs, which take language, sentences, and show you what the velocity time graph looks like. And that's the master level that starts up in the master level. And finally, starting in the wizard level, we got match that graph, which compares position time and velocity time graphs. So I'm not going to take the time to go through all of those in every different combination. One more. And this describes dot diagrams in general. So if you aren't familiar with dot diagrams at all, this is actually the beginning of this video shows you what dot diagrams are about. And so I've created a chart that's similar. I said apprentice level here, but I think a lot of this is now applicable to all of it. I added a few things, and it kind of is a lot of what's going on. So it's got the things you're used to if you've been watching my videos. Something stationary, it's going to have a horizontal line on a position time graph. On a velocity time graph, it's going to just be at 0 all the way across. A dot diagram would just have one dot dropping in the same place the entire time. So if something's going slow, it's going to have a small slope on a position time graph. It's going to be close to 0 on a velocity time graph, and your dots are going to be close together in a dot diagram. If something's moving fast, it's going to have a steep slope on a position time graph. It's going to be far from 0 on a velocity time graph, and the dots are going to be far apart. Again, if this is going too fast, go to those linked videos, and they'll help you understand it in much more detail. If something's moving right on a position time graph, it slopes upwards. On a velocity time graph, it's in the top part of the graph, the positive part of the graph, and the dot diagram, you'll see an arrow pointing right. If something's moving left, then it's going to slope downward on a position time graph. It's going to be in the negative part of the graph, which is the bottom half of the graph, and you'll see an arrow pointing to the left, meaning it's moving left. If something has constant velocity, it's going to be sloped. Just really quick here. Remember, if it's sloped this way, that means it's moving positive. If it's sloped that way, it's moving negative, which we just said up here. On a velocity time graph, you just see a flat line because it's keeping that same velocity the entire time. And again, the dots are equally spaced. If something is accelerating or changing speeds, you'll see a curve. So keep in mind that curve might be flat to steep or flat to steep, in which case it's starting out slower and speeding up, or it could be steep to flat or steep to flat, which indicate it's slowing down. It's starting out steep fast, ending up flatter, and that would be slowing down. Okay, so you could have either of those types of accelerating, speeding up or slowing down. The velocity time graph will be sloped. You'll see it sloping away from 0 if it's speeding up, or you'll see it sloping towards 0 if it's slowing down. Again, all of that I just went through is in those other videos. If you see the dots spreading out, if it was going this way, that means they're getting faster and faster as they get farther apart, so that would be accelerating. That would be decelerating. This would be accelerating, and this would be decelerating or slowing down. All right, so again, all of that you can go to those linked videos to get more detail on. All right, the one thing that you'll see new that I don't think I've talked about are data charts. So you'll see something like this where they measured at a certain time, okay, at a certain time, what position was the object at. Okay, so this particular one, you can see at time 0, it was at 0. After 1 second, it had moved 3 meters from 0 to 3. After 2 seconds, it had moved from, during that second second, let me say it that way, during that second second, it had moved from 3 to 6. That's another 3 meters. So every second, it's moving 3 more meters. That would be constant velocity, because every second it is moving 3 more meters. That's the same speed the whole time. You might see a graph like this. Okay, it starts out at 3, it's still at 3, it's still at 3, it's still at 3, it's still at 3. This thing is not moving. It's stationary, or another term you might see is at rest. Next one you might see, we change 1 meter during the first second, we change 3 meters during the second second, we change 5 meters during the next second, we change 7 meters during the next second. This thing is changing its speed. It's going a different distance each second, going more and more and more, so that would be accelerating. If it was getting less and less, like you had 10 and then 5 and then 3 and then 2, the difference was that, then that would be decelerating or slowing down. There are some like that. I didn't write any tables like that. Okay, but if the position is changing by more and more, it's accelerating faster. If the position was to be changing by less and less, then it would be decelerating. All right, and if you see a negative in here, just remember that negative means that it's moving to the left. Okay, assuming the negative numbers are getting bigger and bigger. All right, then you'll also at sometimes see velocity time data charts. So don't forget, these are measuring velocity. So you got to look carefully and think, is this measuring position? Is this telling me where it is? Or is this telling me how fast it's going? Okay, so at time 0, it's not moving at all. It's stationary. After 1 second, the speedometer reads 3 meters per second. After 2 seconds, the speedometer reads 6. So you can see the speedometer is getting bigger and bigger. That means it's getting faster and faster. That would be, oops, those came in the wrong order. Okay, let's just put them all up here. Okay, that would be accelerating, okay, because each speed is getting faster and faster. Then in this one, you can see the velocity is staying the same the whole time. So this would be constant velocity. The speedometer is reading the same thing, and it's not 0, because if it was 0, it would be stationary. Okay, so when the velocity is staying the same, that would be constant velocity. And finally, you could have constant velocity moving to the left because of the negative numbers. We define right positive, left negative. All right, so let's just do one sample problem, and then you can puzzle it out. And I would highly encourage you, if you're having trouble like recognizing position time or velocity time, if you're having trouble with those ones, go back to the links that I showed you at the beginning and see what you can find. All right, so as we look at this one, first thing, we'll just start with the first one. The object is slowing down. Okay, so the first thing we might think is, let's go through and try and find one that doesn't belong. In other words, find one that's speeding up or staying at constant speed. Okay, well, let's see what happens here. This one starts out going fast, and then it starts to slow down because they're getting closer together. Okay, it's not going as far each second. So that one is slowing down. Okay, how about this one here? It starts out with a steep slope, which means fast. This is a position time graph. And it ends up with a flat slope, which means slow. Okay, well, that's slowing down too if it's going from fast to slow. Okay, well, how about this one? This one starts far from 0. That would be fast. And this one is slow. Okay, so that one also is going from fast to slow or slowing down. Well, let's see what's happening here. This changes by 8. This is position time. So it covers 8 meters. Then it covers only 4 meters. Then it covers only 2 meters. Then it covers only 1 meter. That's covering less and less distance each second. That means it is slowing down. So actually all of them are slowing down. So that's not what's making them not belong. Well, let's look at this. This says the object is moving to the right. Do all of these have the object moving to the right? This one isn't specific, so that can match fine, because this would be true of something that's moving to the right. Okay? Position. Well, the top of the graph up here is going to be the right, and the bottom is the left. So this is moving from the right to the left. So this one is going left. Okay, so at this point we have one that's going right and one that's going left. Well, let's see. This is in the top half of the graph. The top half of the graph is going right. So now we've got 2 that are going right, and these are positive numbers, so these are also going right. So the one doesn't belong is the one going to the left. Okay, so as you go through these, the first thing you look for, they might all be that way. Okay, or they might all be that way. So you might have to look for a second thing. Like in this case, we looked for slowing down being the thing that one of them wasn't slowing down, and it turned out that one of them wasn't going to the right. One was going to the right. The rest were all, we had 3 going to the right and 1 going to the left. So that one was the one that's different. That's the one you would pick. You would select the one that does not belong, because the rest of them are all describing the same motion. All right, and that is it. If you have any questions, feel free to put them in the comments below. Again, be sure to use those links to figure out some of the things that you might not have caught as you went through the unit that you might need to review. Go back to those videos and then use the chart that I've got to help you out. Here, let me put you back to the chart real quick. Oh, I'm not on mouse, that's why. So let's go back to the chart, and there you go. That has most of the information except for the data charts, which you'd look through there. All right, well, we'll see you the next time. But don't forget, if you enjoyed this video and you got through it, make sure you click that like and subscribe button for me, and then we'll see you the next time on the scientific adventures of Beardman.